The Quick Start Bar scatter option in ASAP now includes directories of texture models from Alanod, MoldTec, and Tenibac. These are commercial manufacturers of texture standards that are often used in architectural, automotive, or other forms of illumination. Within each of these directories, we have several sets of measured data for the different materials, and they can be drag and drop to place them into your ASAP model. What we're seeing here is the results of an analysis using a particular model, in this case MoldTec's 11200 material. What we see is the light coming in this case one ray incident on the diffuser surface, and we're scattering a large number of rays, but rather than letting the rays scatter into the hemisphere as would occur on an actual surface, we're scattering the rays towards a particular region of interest. This is a capability of ASAP that can be used to significantly speed up your ray tracing, because rather than letting the rays scatter into their full hemisphere, you only worry about those rays that scatter into a particular region of interest. And what ASAP will do is to adjust the energy in those rays so that the amount of energy captured, even though it's all of the scattered rays, the amount of energy has been reduced to represent that would actually be going into that angular subtense. And if I look into my command output window here, what I see is the energy captured in that region, and this is based on a baseline unit of 1 watt energy coming from the source. And if we look at this plot here, what we're looking at is the area distribution of the energy over that region. And we can see that the light is scattered. Most of the energy, or the higher energy concentration, is towards the edge, and then as it moves away from that region, the energy gets reduced. To change the model within the file in ASAP, all I need to do is to come over to my Quick Start bar and select a different material and simply drag it and drop it into my ASAP file. And rather than going and modifying my file to select model number 2, I'm simply going to comment out the first model. And let's bring these graphics back forward again. And now what we'll do is run this same analysis, but using a different scatter profile. And here's the ray distribution, and here is the energy display. And if we bring the two displays forward, what we can see is that for the second case, we have a much more concentrated distribution of energy. Less energy out here, and we can see there was, again, more scatter out here. However, this is a relative scatter measurement, because you'll notice the total energy captured on the detector is actually reduced from what we saw in the first case. So in other words, the amount, although more energy is here, relative to out here, it's actually less total energy.